Hi there. Well, we're going to be looking at solving some equations. These will just have some decimals in them, but again, I just encourage you to use a calculator when you're solving these. But it'll be a good review. So here we're going to start with E, and when you're solving these, this is 5.7. But anyways, when you want to get the x by itself, this is 8 times x. So you would divide by 8 to separate the x times the 8. So we would divide and they cancel. See, the whole goal is to have a 1 in front of your variable, a positive 1 in front of your variable. Well, 8 over 8 is 1. So we have 1x equals, and then 42 divided by 8 gives us, we'd have to reduce it. Or I think in this section, rather than leave it as a fraction, they want a decimal. And they may have to tell you where to round it off to, but just take 42 divided by 8. So you come up with 5.25. So if you were to take 5.25 times 8, you'll get 42. So you can check them. So again, we're not going to be reducing fractions. Yay. We're done with that. We're just going to be making our answers decimal form. Okay, just like on on E, and I don't know why they went with E, and oh, it doesn't matter. 6. All right, so here we have a negative 2.6 times y. Now remember, I want a positive 1 here in front, so I'm going to divide by a negative 2.6. So the sign stays the same. A positive over a positive is a positive 1. A negative over a negative is a positive 1. So we'll have positive 1. Whatever you do to one side, you do to the other side. So now you would take 3.38 divided by a negative 2.6. So when you're dividing to get rid of a number here, when you're dividing, the sign stays the same. So now we're going to take 3.38 divided by negative 2.6. And we're going to get a negative 1.3. So if you were to take a negative 1.3 times a negative 2.6, you're going to get a positive 3.38. Okay? All right, so that's how you solve if you have 8 or if you have a number times your variable. But here I have my variable and I'm subtracting 0.72. So to get the t by itself, you will add 0.72. And this is when you've got the opposite. I haven't been drawing that line, but just remember, whatever you do to one side of the line, you do to the other. Okay, and it's that equal sign that has that line through it. So whatever you do to one side of the equal sign, you do to the other. I didn't put my 0 in front of my decimal, but that's okay. So those cancel out. And then you can just take 11.1 and add 7.2. And you come up with 18.3. So 18.3 subtract 0.72, you will get 11.1. So you just need to be really familiar with when are you adding the opposite, when are you dividing, things like that. And when do you add the opposite? When do you divide when you have a bunch of them? All right, let's look at number 8. We're just going to go through some of these. Again, having a calculator, it's not too bad. It's a good review of solving. So on this one, I have t subtract 5.4 on the right-hand side. It doesn't matter if the t is on the right or if the t, let me go back up here, if the t is on the left. It needs to be by itself. All righty. So here for number 8, I've got to get rid of the minus, the subtracting of 5.4, just like I got rid of the subtracting of 0.72. So I'm going to add 5.4 to both sides of the equal sign. And you can draw a line through that equal sign if it helps you to know that you've got to do something to both sides. So that's done. We have a t. That's the only thing, and it has a 1 in front of it. So that part kind of done. So then you would just take a negative 14 plus 5.4. Oh, negative 8.6. Now here you can put the t here, you can swap sides. So that's kind of nice. You can do that, you're gonna swap them both. So if you were to take a negative 8.6 and subtract 5.4, you're going to get a negative 14. All right, so number 9 and 10, they take both of these ideas and put them into one problem. So we're going to be doing both processes. We'll be adding the opposite, and then looks like we'll be dividing to solve. You always get rid of what's being added or subtracted first. All right, so these are just called two-step equations, and we're going to do some here in a minute where it's going to take multiple steps other than just two. But for now, we have plus 1.3. This is the times. So you leave that alone when they're next to each other. You leave that alone till you get rid of the other stuff. So minus 1.3. To both sides of the equal sign, to the left of the line and to the right of the line. So that gives you 3x equals, we'll take 5.2 minus 1.3, 3.9. Okay. Now you get rid of what's being multiplied here. Now, if we had a division of 3 here, we'd do it now. So you get rid of what's being multiplied or divided at this last step. So if we have a 3, I want a 1 there. 3 over 3 is 1, but whatever you do here, you have to do here. So we have our 1, those cancel. We have our 1x. Notice I'm leaving the x. Some people always want to put an x down here, but the x stays. We want to get rid of the 3. All right, so it's just an x equals, looks like we have 1.3, 3.9 divided by 3. So to check it, I would take 3 times 1.3 plus 1.3, and you should get 5.2. Be great. Let's do another one. And again, what you can always do, if you do struggle and it's been a while since you've solved equations, you can always stop the video and try them and then watch and make sure you get the right answer, because you really learn more by doing than you do by watching. All right, so well, whatever works best for you. Here, this is a subtract 6.7. So I'm going to, let's get over a little bit. So I'm going to add 6.7 to both sides of my equal sign. It's always the opposite here. So now we'll have 1.8 by itself. Let me put that in there. 1.22 plus 6.7, 7.92. So to finish this, I need a 1 here in front of the x. So this is 1.8. I'll divide by 1.8 so that the 1.8s cancel. Divide by 1.8. So now the x is by itself, or it's got a 1 in front of it, because 1.8 over 1.8 is the number 1, like 3 over 3 is 1, 4 over 4 is 1. So x equals 7.92 divided by 1.8, 4.4. And again, you could put that back in, make the x, so you take 1.8 times 4.4, when they're next to each other, you multiply. Subtract 6.7 and you'll have 1.22. All right, let's keep practicing this idea in this section. And again, if you've got it, you can always fast forward. But some of these later on, like number 18, 17, some of these will be a little bit more difficult. So you may have to come back. All right, so number 11, again, we need the x by itself. It happens to be on the right-hand side, but the process is still the same. I want it by itself there. So I need to get rid of the plus 7. So when it's next to it, that means multiply. That's done last. You're going to get rid of the 6.2 last. But here we're going to subtract 7, subtract 7. So I have 6.2x equals, because 7 minus 7 is 0, it's gone. So then we add these two together, you'll get a minus, what's that, 16.74 when you add those together. And you can do that on your calculator if you need to. Now I need to get rid of the 6.2. I want a 1 in front of the x, so I will divide by 6.2. But notice I'm not dividing by the opposite, because if I did, I would have a negative 1. I want a positive 1. So when you're doing this last step here, the signs always match, positive, positive. Because I want a positive 1, and a positive divided by a positive is a positive 1. So I'm going to use my calculator, negative 16.74 divided by 6.2. A negative 2.7. So if you were to take 6.2 times a negative 2.7 and add 7, you'll get negative 9.74. Okay. All right. Well, let's go ahead and look at, let's see, number 13. I don't want this video to go too long. On number 12, you would subtract 18.26. Well, let's go ahead and do these just in case. Like I say, you can always fast forward if you've got the concept. So this is being added, so I'm going to add the opposite. This is the only time when you have the opposite is when you're getting rid of an entire term. So minus 18.26. Shorten that up a little bit. So that adds up to 0. So we just have a negative 8.5y. And then we'll take a negative 31.04 and subtract 18.26, or add a negative 18.26. Negative 49.3. So either subtract or add a negative. Your calculator will do that. There is a difference between a subtraction and the negative on your calculator, so watch that. Okay, I want a positive 1 here in front of this y. I need to get rid of this. So I'm going to divide by a negative 8.5, because a negative over a negative is a positive. Negative 8.5. This one, negative over a negative, is a positive, because when you have an even number, it's positive. 5.8. So again, you can put the 5.8 in, multiply it, and add 18.26, and you'll get negative 31.04. All right, now let's look at 13. 13 may look a little different. And again, whatever the number that's right next to the t is the last one you get rid of. So you need to get rid of the 7 first. Okay, so here you would subtract 7. So negative 1.5t. So that's a negative there in front. You could even go plus a negative if you wanted to. So what's left is this, because that's 0. Whatever you do to the left, you do to the right-hand side of the equal sign. So that leaves you with equals 2.1. 9.1 and a negative 7 or minus 7 is 2.1. So on the calculator, if you needed to, you would take 9.1, subtract 7, or 9.1 plus a negative 7. Both ideas are the same. Subtracting and adding the opposite is the same. So now we're going to divide to get rid of this multiplication here. I want a positive 1. So they cancel, leave you with a 1t. Okay. So I'm going to use my calculator on that one. 2.1 divided by negative 1.5 is a negative 1.4. All right, there we go. All right, so now we're going to look at these next ones here. Get these 5. And these are going to take more steps. All right, so it's more than just the 2 steps or the 1 step. So I'm going to go ahead and cover up some of these. And we're going to look here. Okay, first thing is you always make sure that you've simplified the side first. Is there anything else that I can do here or here? Well, you cannot combine these because the 3 does not have an x. It's not a like term. So there's nothing you can do here anymore. I can't simplify this any further because you can't, the 15 does not have an x. So they need to stay separate. So now your next step, once you've simplified the sides, then you, just one moment, please. Once you simplify the sides, you're going to start moving. So you need to move. So the first step I suggest you do is notice how you have x's on the right and x's on the left. I'm going to go ahead and move this x over here. So I'm going to move this entire term. I'm not going to separate the 4 and the x. That would require division to separate those two. I want to move that entire term to the other side. Well, I've got these little smiley face things, so I'm going to recopy it. So I've got 7x minus 3. So I'm going to take this and move it to the other side. So when you're solving an equation for a particular variable, you do need that equation. You do need those variables on one side. All right. So I'm going to take the 4x and move the entire 4x. When you want to move an entire term, you add the opposite to both sides. And I'm going to put it under like terms. So there's my equal sign. So I'm going to add it to the right of the equal and to the left of the equal. I put it under the 7x so that I have like terms. So that, boy, that's a funny looking 4. Go down 4. All right. Much better. Okay, so that way here, those are gone because 4x and a negative 4x is 0. So that leaves me with 3x. I still have my subtract 3. So there's an extra step here, and that was moving that 4x over to the other side. Now, if you're having trouble with this, I highly suggest, even if you get it right, that you do a similar question so that you can practice, because that's all it takes. It just takes a lot of practice. So we got rid of this and moved it over to the left. And again, when you're moving the entire thing, rather than separating the 4 and the x, that's division. To move the entire, you add its opposite to both sides. So 4x, negative 4x. 7 and a negative 4 is 3. So now it's your 2-step. You add 3 to get rid of the minus 3. So 3x equals 18. Divide by, now you want to separate the 3 and the x. Now it's not moving the entire 3x over. I just want that 3 to become a 1 in front. So I'm going to divide by 3 because 3 over 3 is 1x. We don't put the 1 there, but it's there. They cancel and give you a 1. But you have to divide that by 3. You have to stay balanced. So you get 6. So your answer is 18 divided by 3, which is 6. All right. So again, if you were to go back to your original, 7 times 6 is 42. minus 3 is 39. 4 times 6 is 24, plus 15 is 39. So again, you're getting the same answer when you put it back in on both sides. The left and the right should be equal to each other. All right, so we have an extra step. We've added an extra step is all. All right, so let's look at number 15. We have some decimals, but that's okay. Now, go ahead and see, can I combine the 2.9 and the 83? Could I add them together and get one number? Because the 83 does not have an A, so it has to stay separate. Same thing over here, but always check to see if you can simplify the side, and that'll make more sense as we go on. All right, so now that we know we cannot simplify, they're not like, cannot simplify, they're not like, I'm going to solve it for the A's, but you cannot have your variable on both sides. So you have a choice. When we deal with inequalities, I just move it over to the left. Some people don't like that because if I add a negative 4.2a, you're going to get a negative over here, but I'm thinking, you got a calculator, it's okay. And when we do inequalities, we always move the variable to the left. We always move it to the left. So let's just move it to the left. Minus 4.2a. You can add a negative 2.9 if you want to. Okay. So what I'm doing is I cannot have variables on both sides, so I'm adding the opposite of this one to get rid of that one. Okay. So it's not here. I'm going to shorten that up. So now we have 2.9 plus a negative 4.2. I'm doing the A's here. That's a negative 1.3a. I still have the 83, and I still have the 18. So when you move an entire, when you want to move everything, you add the opposite to both sides, and that'll always move it. Get rid of it and move it over here. It's always the adding the opposite. So now we get it by itself, our two steps. We'll subtract 83 to get rid of this right here, or add a negative 83, the same idea. So I subtract 83, subtract 83. So we have negative 1.3a equals 18 minus or plus a negative 83. Either use a subtraction or plus a negative. Negative 65. Now I want the a by itself. So I don't want to move the entire term over. I want to separate these two. I want that negative 1.3 to be a positive 1. So I divide by a negative 1.3. That gives me a positive 1. And when they cancel, you end up with a 1. It's positive because a negative over a negative is a positive. See, this is going to be positive, a negative over a negative. So a negative 65 divided by a negative 1.3 is 50. Do I have enough room to write the answer? 1A equals 50. And you could put that back in for your A's, and the left should equal the right. All right, let's look at number 16. If we have to add another step. So we're going to just keep adding some steps each time. Let's see, how many more steps do we have? Yeah, we have, all right, a few more. So in this one, what you'll have to do is use the distributive property first before you start moving things. So this is kind of a form of simplifying. I'm going to redo my arrow. So when you have a number out front, you're going to take and multiply that number to whatever inside. And this time we have two things inside. So when I do that, I get 4 times 1, because remember there's a 1 in front. We just don't write it. 4 times 1 is 4y, plus 4 times 2 is 8. 9y subtract 8. Nothing over there. Now it's just like 14 and 15. Now, some people may want to subtract 4y. That way you're dealing with a positive because you have a positive 5. It doesn't matter. You can subtract 9. All right, either way, it's fine. I'm going to go ahead and move it all to the left. So again, I wanted to move this entire term over. So I'm going to get rid of it. I want to get rid of the entire thing. So I'm going to add its opposite. That will get rid of it over here. Minus 5y, when 4 and a negative 9 is a minus 5. Plus 8. Okay. The only thing that's on that right-hand side now is the negative 8. I got rid of the 9y by adding its opposite to both sides. And so now we have our two-step. We get rid of what's being added first. That's a minus 5y equals negative 8 over a negative 8 is a negative 16. Okay. All right. And so now then to get a 1 in front of the y, to get rid of that negative 5, I want the y to stay. So leave the y alone. I want that y to be there. I'm going to divide by a negative 5. You get a 1. They cancel. You get a positive. Negative over a negative is a positive. And then 16 divided by 5 is 3.2. Positive. Negative over a negative is a positive. Okay. All right. Let's try. And then you could put the 3.2 back in. 3.2 plus 2, and then take it times 4. Will be the same as 9 times 3.2 minus 8. So you can check it. All right, let's look at 17 and 18, and we'll be done with this one, with this section. Let me just turn the page over. Okay, 17 is very similar to 16. It's just that it has a lot of decimals. But let's look at our left-hand side. Is there anything to do? Well, that doesn't have an x. So I cannot combine those, and there's no distributive property. So that's going to stay. So I'm going to write negative 2.33 plus 6.1x. Okay. Now over here on the right-hand side, I'm going to use the distributive property, just like that. So let's see, 11.7 times 3.3. 38.61. Then I'm going to take a negative, or excuse me, 11.7 times a negative 1. And a positive times a negative is a negative 11.7x. All right. So again, make sure you understand using the distributive property, it's a multiplication to both of those. Once again, I have x's on both sides. I got x's on the left and I have x's on the right. Let's get rid of the x's on the right. Let's get rid of these by adding the opposite. So plus 11.7x, 11.7x, positive. That's a positive. So they're gone on the right-hand side. If you have a negative 11.7 x's and you add a positive 11.7 x's, you don't have any. They 0. So we still have the negative 2.33. We have 11.7 plus 6.1. Okay, those are similar, so we'll add them together and get 17.8x. Okay. And then on the right-hand side, we still have the 38.61. Now now we have the x's on one side. So we added the opposite over here, brought all that whole thing over, got rid of it here. So it ended up over here. And now we need to get the x by itself. We get rid of two things. If it's right next to it, that goes last. So we're going to get rid of this. It's actually what's being added by adding the opposite. So we still have the 17.8x. Here we're going to end up with 49 carry the 1, 4. 40, notice I lined up the decimals, and because you have to add some common denominators. Those are tenths and those are hundredths. So now to get rid of the 17.8, because I want to create a 1, I'm going to divide by 17.8. So I'm not going to do that in my head. 40.94 divided by 17.8. 2.3. And again, you could put in your calculator a negative 2.33 plus 6.1 times 2.3. And then take 38.61 and subtract 11.7 times 2.3, and you'll get the same number. That's how you can check it. All right, grand finale for this section, number 18. Okay, got a bunch of stuff to do here. So again, we're going to concentrate on the left side of the equation, then we'll go to the right and see what we can do. And then once we've simplified the left and we've simplified the right, we'll start to move stuff. Get the x's on one side and get the x by itself. So here, let's go ahead and take 2 times 3 is, we're going to use the distributive property. Oh my goodness, excuse me, the pencil lead just really came out. Okay, so we're going to take 2 times 3 and 2 times 7.5. That's going to give us 6 minus, because 2 times 3 and 2 times this is 15x. Okay. So 2 times a negative 7.5, you still have, it's a negative 15 or a minus 15. Okay, that we'll keep that as a subtraction rather than make it plus a negative. Okay, over here, you have to use the distributive property first. There's a couple of things we're going to have to do on this side, but the first thing is we multiply through, because remember, you can't add those together because the 35 doesn't have an x. So we're just going to have to use the distributive property because you cannot combine those. So we're going to have 8x. 4 times 35, 140. I just want to make sure. 35 times 4. Oh, that's something weird in there. 140. Yeah, that's right. So 140. Okay. But you still have this plus 15.5 out there as well. All right. So we're going to have to, we're not done simplifying that side. Need to move this up a little bit. All right, so over here, these two are like terms. So I did the distributive property. Now I need to add these two together before I start to move stuff. $8x, when we add those, we'll get plus 155.5 when I add those two together, 140 and 15.5. Now we're ready to move things from left to right. And again, you need to recognize that you've got x's on both sides. So let's just go ahead and take this 8x and get rid of it, because you cannot have the x's on both sides of the equation. One of those sides has to go. So you either add 15 to get rid of this one, or you subtract 8. Let's subtract 8. Because, one of these days we're going to do inequalities and you have to move them over to the left. so that they're easier to read. All right, so looks like we have the 6, minus 15 and a minus 8. All right, is a minus 23x. So all I did was bring that over. So now we're going to get the x by itself now that we have x's only on one side. So the first thing I'm going to get rid of is the 6. All right, because that's next to it. So, and you can even go plus a negative. You could have even done plus a negative at the beginning if you want to. So yeah, when you're combining those, you get this. So subtract 6. So a negative 23x equals 149.5. Okay, so now then, plus 6. You need to get the x by itself. Last step. So we go and you want a 1 here. So you subtract 23. So and then you subtract 23 on both sides of that equation. So we've got a negative 23 here. We're going to divide by a negative 23 here. And again, some people put an x right here, but you don't want to get rid of the x. You want to separate those two from each other and leave the x. So here, these cancel out. And you take your calculator, 149.5 divided by a negative 23. We know it's going to be negative, so a negative 6.5. And you can substitute that back in and check and make sure the left equals the right. All right. So, again, if you struggle with this, do similar. And, and if you still struggle with solving equations, let me know and we'll Zoom. And I can hopefully get you straightened out. All right, so now what we're going to do is look at the last section of this chapter here, which is 5.8. Now, 5.8 it's a translating, it's what it is. And so you're taking an English sentence and putting it into math language. So really, if you think about it, when you're doing math, you're learning a foreign language is what you're doing, because it is a foreign language. We have different symbols for different words. So here we're going to be translating. Now, our first translating, well, here, let's do, I don't normally do this top part here, but let's try it. Decreased by. If it said a number is decreased by 10, what would you do? Would you add, subtract, multiply, or divide? Well, decreased, if you decrease something, you're subtracting. So when you see this word, we will put in a subtraction symbol. Didn't like my hand reaching in there. So this would be a subtraction. If you see that word, you'll put a subtraction symbol in. Quotient, which we talked about earlier, quotient is the answer in division. So if they want the quotient of two numbers, you're going to divide the two numbers. Twice. If you want twice, twice the number of apples, twice the number of anything, you're multiplying. All right, when you want it twice, so like twice the number n would be 2n. Twice x. All of these mean twice the number, whatever the variable happens to be. So it's a multiplication of 2. Twice means a multiplication of 2. 2x, 2n, 2y, whatever. So it's C. More than, if you have 6 more than someone else, then you would add. So more than is addition. So that's just kind of some of the words. And so we're going to practice that. We're going to translate a sentence into math. What about how they keep putting an E there, and I'm not really sure what's going on, but that's okay. All right, there are two that you kind of have to watch. Normally we read from left to right, and so as we read from left to right, we put symbols in for the words, except twice. There's two instances where you have to read backwards, and that's with less than and subtracted from. So less than those words and also subtracted. If you have these, you put this one here. So if we have 5 less than n, you go, instead of reading left to right, it's n minus 5. All right, 5 less than some number n. Subtracted from, if you have 9 subtracted from y, you read backwards. So it's y minus 9. Those are the only two exceptions right now that you're responsible for. And otherwise, you can read from left to right and just write symbols as you come to them, except those two. Less than, you put down, you go to the end and write it first, minus 5. Y minus 9. Okay, those are pretty easy to remember. So let's look at this E. Why they didn't put a 5, I have no idea. 8 less than some number. So because it's less than, we're going to go over here first and read backwards. Some number. Now sometimes they'll tell you what variable to use, what letter, but here it doesn't matter. So you can use n for a number minus 8. Okay, so you're done. You've translated it. Okay, let's look at number 6. The product. Well, that was one we didn't talk about earlier, but we should know that product means multiply. So you'll be multiplying 5 and some number. So multiply means put them next to each other in algebra. That means 5 times some number. So this would give you the product. If you multiply, you're going to get the product, the answer in multiplication. And I chose n, and they don't care. And on MyMathLab, they may tell you what variable to use. All right, let's do number 7. Let's translate. 10 increased by some number. If you're going to increase something, we're adding. So we're going to take 10, and I can read this from left to right because I don't have a less than and I don't have a subtracted from. So 10 increased by some number, 10 plus n. Now this is the same. Order does not matter in addition. So you could have either one of those, 10 plus n or n plus 10. So order doesn't matter. It doesn't matter here either. You could have n times 5, but by convention, we call this the coefficient, we put it in front. But like 2 times 3 is the same as 3 times 2, so order doesn't matter. Order does matter though in subtraction and division. All right, let's do it number 8. The product of two numbers plus 12. So now I'm getting a little more complicated. Product means we're going to multiply. So we're going to multiply two numbers. We don't know what those numbers are, so we're going to use variables. How about A and B? So the product of two numbers. I chose A and B, X and Y, M and N, doesn't matter. They're next to each other. That means I'm multiplying two different numbers here, A times B, plus 12, AB plus 12. So that's the product of two numbers. I chose to use A and B. You could have done X times Y or m times n. It doesn't matter as long as you're multiplying them. And in algebra, we put them next to each other. That means multiply. Okay. Number 9. Okay, number 9 is a little bit more difficult, you know, because you're taking 1/5 of the sum. So you're not taking 1/5 times a number, you're taking 1/5 times the sum. So what they want here is they want 1/5 the sum. I'll use X and Y. So this is 1/5 of the sum. They want you to find the sum first and then take 1/5 of that sum. So we have to have parentheses. That means do it first, right? With PEMDAS, do the parentheses first. So that is 1/5 of means times, but the sum. So that means you had to add them first. 1/5 of the sum of two numbers. And again, I just chose X and Y. Number 10, the difference between a number and 34. Now, the order matters in subtraction. So you need to know, is it n minus 34 or 34 minus n? Well, this is the word difference, not less than, not subtracted from. Because it's not either one, you just read from left to right. You don't switch the order. The difference between a number and 34, n minus 34. Okay, we're gonna do a few story problems. You know, some of them shouldn't be too bad. Some might be a little bit more difficult, but maybe not. But let's practice a few of these and be done with this chapter. Then start chapter 6. All right, we have a group of 12 social studies students who are earning money for a trip to Europe. After a car wash, they had earned $825.60. After dividing the earnings equally, how much did each student have to put towards the trip? Well, they've told you what to do. They've told you that this is a division problem. So we're going to take the total, 825, and we're going to divide it into equal groups. And there's 12 of the groups, 12 students. I would definitely reach for my calculator. 825.60 divided by 12 students. Each student is going to get $68.80. Okay, so when we're dealing with money, we round off to the nearest hundredth, the penny. Okay. All right, so, you know, it says 0.8 on the calculator, but make sure you put 80 cents. So $68.80 is what each one would get towards their trip. Okay. Here we have another one. At the county fair, the award-winning watermelon weighed 212.6 pounds. That's a big watermelon. This was 28 pounds. So this, meaning this, okay, this was 28.4 pounds more than the previous years. So this one was 28.4 pounds more than what it was the year before. How much did the previous year's winning watermelon weigh? Well, if this one is this much more, if I took the 212 and subtracted the 28, I would have the previous year. The previous year is less than this. It's 28.4 less than this. So you take this minus 28.4. 0.6 minus 28.4. So the previous year was 184.2 pounds. I'll just use that symbol for pounds. Would be that answer. So reason through, you know, did you want a smaller number? Did you want a larger number? You know, so, and you should be able to tell whether or not you're dividing or multiplying as well. But let's keep practicing a few more. Amy, it's the last one that's kind of tough, but we can get it. Amy makes $11 $6.44 for the first 40 hours she works each week. She gets 17.16, which is time and a half. So to find that, you would have taken this times 1.5. That's time and a half. So take your original times 1.5, and you'll get this. For any hours that exceed 40 hours, normally 40-hour work week is pretty standard. Anything over that, you get time and a half. If she worked 51 hours one week, how much is her pay? Well, out of this right here, the first 40 hours, she got regular pay. So you would take 40 times, well, I'm going to use parentheses because I have decimals. It's too many dots. So that's how much she's going to get paid for the 40 hours. That's how much per hour times the number of hours. But she also worked 11 hours overtime. So I'm going to add that in. She worked 11 hours overtime, this minus the 40. But she's going to make more for these hours. She's going to make 17.16. Okay. So you can find out the regular pay, find out her overtime pay, and add the two together. I'm going to go and do them separate. You may have a calculator that do that all at once, but I'm going to do them separate. Ooh. 40 times 11.44. So her first 40 hours, she made $457.60. Then she worked 11 hours overtime. That's how many hours it was over the 40. This minus 40. So 11 times, and you're making more. She made $188.76 overtime. So what did she make? Add those two together. You know, you need to know how to do this. Sometimes employers make mistakes, and you want to make sure that you're getting what you earned. And like I say, time and a half is pretty standard. And to go from here to here, if it's time and a half, you multiply by 1.5. I didn't even check to see if they got it. Times 1.5. Yeah, 17.16. That's how you find out your overtime pay per hour. Okay, perfect. That one wasn't so bad. Let's look at 14. I'm not sure if this is Jolene or Jolene. It doesn't matter. But anyway, she has this much money in her checking account. After she pays the mortgage of $986.56, writes a check for $121.47 for the electric bill, deposits a paycheck of $1,549.32, and uses her debit card for $89.31 purchase. What's her new balance? All right, well, this one shouldn't be too bad. We start out with this much in the bank. She pays her mortgage. The subtraction. She writes a check. She deposits her paycheck. And she uses her debit card. Oops, that's a big subtraction, but that's all right. What's her new balance? That's, you just go ahead, and it's all addition and subtraction from left to right. So we'll do the addition and subtraction from left to right, no multiplication in there or anything, which is kind of nice. 2,657.32 minus 986.56 minus 121.47 plus 149.32 minus 89.31. Looks like she's got $3,009.30 in her account. And again, 2 decimal places when you're dealing with money. Well, she ended up with more than she started with. That's good. All right, questions there? All right, now let's look at this last one. Isaac worked 7.5 hours at a deli shop one day. He spent 2 hours more working the checkout counter than he did in the kitchen prepping sandwiches. So he's working in the checkout counter and he's prepping sandwiches in the kitchen. How many hours did he spend on each task? All right, so what I'm going to do is, okay, we've got, he was in the kitchen, and I'm trying to let's see what variables I want to use. And then, or he's at the checkout counter. All right, so if he's in the kitchen and you're going to add the hours at the counter, well, he spent 2 more hours on the counter than he did in the kitchen. So if K is the kitchen, he spent, there's our kitchen, here's our counter time, 2 more than the kitchen. More is add. When I add the kitchen hours and the counter hours, this is the kitchen hours. Here's the counter hours, how much time on the counter. It's going to be 7.5. And you need to solve it. So that coming up with this was a little tough, and it just takes some practice. But solving it isn't too bad. 1K plus 1K is 2K. So I combine my like terms. And now it's a 2-step equation. So we get 2K equals 5.5. Divide by 2. And the kitchen time is 2.75. Okay, when you divide those, double check, but 5.5 divided by 2. Yep. So how much time did he spend on the counter? Well, the counter is 2 hours more than that. So that's 4.75. If you add these, you get the total time, 7.5. Okay. All right. So that kind of gives you something to follow if you come up with something like that on your homework. Otherwise, that covers those last 2 sections in chapter 5. Let me know if you have any questions. Thank you. Bye.